Hello everyone, my name is Wafa Al-Harthi and my fellow presenters are Ghada and Hanan. We will be given a short presentation about our project. The topic is image segmentation techniques in remote sensing. A list of items of presentation are: what is image segmentation, the objective of project, then image segmentation methods, finally implementation of these methods in Python. Image segmentation is a used technique in digital image processing and analysis to partition an image into multiple parts or regions, often based on the features of pixels in the image. Image segmentation could involve separating foreground from background or clustering regions of pixels that share similar attributes like color or shape. Let's understand image segmentation using a simple example. This image consists of multiple classes such as people, car, building, the road, and trees. By image segmentation, we can separate these classes from each other. So how does image segmentation work? We can divide or partition the image into various parts called segments. By dividing the image into segments, we can make use of the important segments for processing the image. That is how image segmentation works. Many techniques are used for image segmentation. Each of them has their different advantages and limitations. So our objective: comparison of these image segmentation techniques, threshold, clustering, edge detection, watershed, morphological snakes. Now the following presenter is Ghada.
Thanks Wafa for explaining the concept of image segmentation. My name is Ghada Al-Shabanat. Now I will explain the techniques of image segmentation. First technique is threshold. Thresholding is the simplest image segmentation method. It is looked up to distinguish between the image background and image foreground and divide the image pixels with respect to their intensity level. We will explain these two methods, mean and also, as a threshold technique, mean used to converting the grayscale image to binary color 0, 1. The values above the threshold range converted to 1 white color and below the threshold converted into 0 black color. This method is simplest method and no need of previous information. Also method, the most commonly used global thresholding method. It is used to segment an image for further processing, such as feature analysis and quantification. This method looks for minimize the segmented image intra-class variances ease of coding. Clustering method is an unsupervised method. It is classifies the image into a fixed number of clusters, in which the number of the cluster might be user-defined or might be found using an algorithm. We will explain these two methods, k-means and mean shift, as a clustering technique. K-mean is one of the most commonly used clustering algorithm. Is an iterative algorithm that tries to partition the dataset into key predefined, distinct, non-overlapping subgroups where each data point belongs to only one group. This method is fast, easier to understand, and gives best result when datasets are distinct. The main shift is a local homogenization technique of non-parametric feature space analysis to find the limit of density function. It is very useful for damping, shading, or tonality differences on localized object. It does not require number of clusters to be specified as an input. Edge detection algorithm refers to the use of different regions of the pixel gray or colors discontinuity detection area of the edge in order to achieve image segmentation. The canny edge detector is among the edge detection methods proposed. It is the most rigorously defined operator and is widely used because it is the most optimal method of finding edges with good detection, good localization, and single response to the edge. Also easy to use and removing of any noise in an image. Now Hanan will continue to explain the techniques.
Thank you, Ghada. My name is Hanan Uthman, and I will complete the method that we use, and then we go to Google Colab to run our code. The fourth method is a water shield based methodology. A water shield is a method that uses topological interpretation. It is represent a hole in the minimum form where the water spill. It is more good for detecting boundaries that are continuous, and the result of the segmentation is more stable. The final method that we use is a morphological snag. Morphological snag is a family of image segmentation that evaluate the curve and surface that represent as a level set function. We use a morphological geodax active counter, which is stable for image with a visible counter. This method is a fast, stable, and strongly solution of the PDF function. Now we will go to Google Colab. So let's look at the code here. We have import library from SK image, which is highlighted. Then we read our data from a Google Drive by using this command. imread will read an image, and plot.imshow will display the image. For better result, we convert the image to grayscale. We have to find the RGB to gray of the image. The first method is threshold. We defined threshold mean function to find the threshold with a mean in the image. This line of code is to compare the gray image with the mean threshold image. This highlight block of code will display the mean threshold. Next, we defined threshold OS2 function to find threshold with OS2 technique. Then this line of code is to compare the gray image with OS2 technique and with square of 2. And then we display the OS2 threshold. Next method that we use is clustering. First, we use clustering with a key mean, which defined a key mean function with a parameter number of clustering is 3. The second clustering is mean shift. First, we defined estimate boundaries with image boundary quietly 0.1 and 100 sample. Then we define a mean shift function with a bandwidth of bounded. A bunch of code here to display the number of estimate clustering. Then here is to display the figure with estimate number of clustering. Finally, we display the mean shift with after we estimate the number of clustering. The third method is edge detection. we use a canny technique for it. In this line of code, we defined canny function to find the edges in the image. Then we label the image. The fourth method is a watershed. We run a sable edge detection. The highlight code is to define watershed function with 10 markers. The final method that we use is a morphological segmentation. We use a morphological geodesk active counter. Here the height of code to evaluate the level set of image. Then here we defined a morphological geodax active counters. Then we show the image. Here is to evaluate the ground truth of image. Then we use the evaluation of ground truth to compare all methods to show the error and partition, false split, false merge. Then here is all the method.